Our next topic that we're going to get into here is on solution concentrations. I know some of you came in a little bit late today, but we talked about next class we need to make sure we have calculators here. So we're going to be doing some solution concentration calculations. So let's go through these. Take a look at these. We talked about solution concentration. What we're going to be doing is this. We're going to be talking about solution concentrations as being the amount of solute per amount of solvent, or the amount of solute per amount of solution. Which of these terms here, which of these units may be used as concentration units? Go 5, 4, 3, 2, 1. All right. Now we're going to talk about these units next class, but I do have a demo here. Don't put your stuff away yet. Good thing nobody picked cubic centimeters because this is a unit of?
Measure. Length.
Not length. Volume. Kilograms is a unit of?
Volume.
Not volume. It's not length. Kilograms? It's not length. What is it?
Weight.
Yeah, weight. We actually call it mass. Milliliters measures what? Volume. Kilometers measures length. So all of these other ones here, though, are ones we're going to be using. Now, nobody picked proof. That's because you're all underage, right? But where do we find proof? You're not underage, huh? All right. Where do you find? You know where proof is, then, don't you?
Alcohol content?
Yeah, alcoholic content, exactly. Right. No, not that you practice it, right? Okay. Anybody know what the proof is, though? Yeah. Just opposite, not half, but twice. The percentage is half of the proof.
Yeah, so that's what I was.
Yeah. Now, do you know where proof comes from? Anybody know where proof comes from? Well, we'll only look at the legal people in here. All right. Well, here's a lesson. And the lesson is this. First of all, in order to prove the lesson, I need someone to donate some money to the Name of Science. Who is the biggest bill in here? In their wallet or purse or pocket? Anybody have a bill that they're willing to donate to the Name of Science? Look at it back. Anybody have a $100 bill? Anybody have a 20? You have a 20? Want to donate it to the Name of Science? Look at it back. Sure. Don't show anybody else how much money you have, though. Don't look here, guys. All right, thank you. So, what I've done here is this. This here is a mixture of water and alcohol. I just made it up here. Dave was watching me. I took some water out of here, and then this is the isopropyl alcohol we put on our hands the other day. And so I made a 50-50 mixture of alcohol and water. And what I'm going to do here now is I'm going to put this bill into the alcohol and water mixture, and I'm going to start up fire here. And then I'm going to take this bill out of here. You said you didn't need this back, right? All right, we'll try it again. And we weren't successful, were we? All right, now, notice that the bill did not burn. Now, why did it not burn? Well, thank you. It'll dry out, promise. No, sorry, I didn't tell you it was going to get wet. But no, here's what happens. Remember that this contains a mixture of water and alcohol. So what happens is the alcohol winds up burning off and leaves behind the water. Okay? And as a result, then that wet bill wouldn't burn because it was now not enough alcohol in there, and the water put out the fire. So the origin of the word proof is this. Now, way back when, and again we use it for which stuff? for liquor, right? Stuff that we drink. Now, back in the days, everybody wanted a cheap source of alcohol, and even for a while it was illegal, so they had to make their own alcohol, which would be the bootleggers, or moonshine, right? And so, if you want to make more money, how do you make more money? You don't want to add alcohol because that's going to cost you money, right? You add more water. Okay, if you add more water, you can sell more of the stuff, right? Now the problem is, you want to buy the alcohol. If you're going to buy the alcohol, what don't you want in there? You don't want to have water. So what they do then is they take the moonshine, they put some gunpowder down, they pour the moonshine over the gunpowder, then they ignite it, and what would happen then is if it was too watered down, the gunpowder would ignite. But if it wasn't watered down, what would happen is that the alcohol would burn off, and so would the gunpowder, and that is proof for it containing the amount of alcohol they said it is. And that amount, it turns out, is about 100 proof, which is about 50-50 alcohol and water, and it was 100% proof that contained an adequate amount of alcohol. So, there's your lesson for the day. Any questions? All right. Remember, only if you're old enough. See you later. The next two questions on the Socrative app are these here, and I'm going to leave these up here for about 3 or 4 minutes, and you can work on these and come up with an answer. You are going to notice as you do them, these labels %V over V, and there's going to be some answers where it's %M over M. And so what you need to know about these is this right here, and that is, you see a %M over M, that stands for percentage by mass. You see a %V over V, that stands for percent by volume. And if you see a %M over V, this stands for what we call a mass volume percentage. And in a mass volume percentage, masses do need to be in grams, volumes will be in milliliters. They either have to be these units here, or masses would have to be in kilograms and the volumes in liters. So it's one of these two options if we're looking at some mass volume percentage. The units on these here are much more flexible. You do a percent by mass, you just basically need the same mass units in the numerator and denominator. If you do volumes, you need the same volume units in the numerator and denominator. You can use any mass units, you can use any volume units for these, as long as the numerator and denominator have the same units. We'll give you about till, let's say about 2:11, so it'll be about 4 minutes to go ahead and work on these questions. So now you should have calculated this answer already, and you should see your answer up here, and if you don't see your answer, then you have option E to choose from. So let's get your answers locked in. We'll give you about 10 seconds here. 5, 4, 3, 2, 1. Correct answer is choice B, which is 20%. 20% by mass of the glucose. Now, if you did 20%, obviously you did it correctly. To calculate this, you would have taken 50 and divided it by 250, not by 200. Which people divided by 200? Well, you didn't have to raise your hand. Okay. But in these choices up here, which one?
25%.
Right, it was 25%. Why wouldn't you divide by 200?
Because you have to add 50 to get the whole.
Right, you have to add 50 to get the whole. Because remember, the definition is you take the part, you divide it by the whole, and then you multiply by 100. So coming back here to see how this works, right here, we take the 50 grams, we divide it by 250 grams, then we multiply by 100, because again, we want to divide by the whole amount, part over the whole. And that's of course why the be careful was in there, because many people forget to do that. When you calculate a percent concentration, it's the solute divided by the solution that we do the calculations. So any questions on that one? Okay, that takes us to the next question. Asks, what is the volume of isopropyl alcohol found in a 1 pint bottle of rubbing alcohol that is 70% by volume isopropyl alcohol? Which, by the way, if you have rubbing alcohol sitting in your cabinet, about 90% of all isopropyl alcohol or rubbing alcohol is this type, 70%. Sometimes it's 90%, sometimes it's 50%, and occasionally you'll find some ethanol, some denatured ethanol out there. So let's get your answers locked in. 5, 4, 3, 2, 1. Correct answer here is 331. 331. Now to arrive at this answer, this works just like all percentages work. If we want to find out what 70% is of the whole amount, we simply take that whole amount, which is 473 milliliters, we multiply it by 0.70, and where does this number come from?
70%.
Yeah, 70% divided by 100. So when you convert a percentage to decimal, you simply move the decimal over 2 places, or you divide it by 100. And so as a decimal fraction, 70% is 0.700. And so I'm sure that if you wanted to find a discount on a purse or a pair of shoes, or a nice motorcycle or something, we all know how to do that. And so this is how we go about calculating it, the same way when we calculate this for solutions. Okay, any questions with this one here? Now, if the question was, let's say we wanted to know how much water is in this bottle. So let's say we want to know what volume of water is there. How do we find the volume of water in the bottle?
Multiply 473 times 0.3.
Okay. Yes, we could multiply it by 0.3. What's another way that's maybe even easier? 473 minus 331. So we could do it this way. Either one of them, we should arrive at the same answer and wind up with 142 milliliters. But again, the other way would be to multiply the 473 by 30%, or by 0.30. Okay? Any questions on this one?